right, today we're going to be talking about and working with quadratic functions. And transformations. Okay, first thing we're going to talk about is vertex form of a quadratic function. And the vertex form of a quadratic function looks like the function of x is equal to a times x minus h squared plus k. Where a is not equal to 0. The vertex of the graph is at hk. And the axis of symmetry is at x equals h. So if you had to graph the function f of x is equal to x squared, what we got to understand here is that if in the function f of x equals x squared, that's the same as f of x is equal to 1 times x minus 0 squared plus 0. The 1 in front of the parentheses that represents this a, it doesn't get written. If you're subtracting or adding 0 to something, it doesn't get written. So your h in this case would be 0. And out here to the right, this plus 0, again, you wouldn't write it, and that's why it's not written in this function, which is called the parent function. So your k value is 0. So if you were asked to graph f of x equals x squared, here's what it would look like. On a coordinate plane, its vertex would be at 0, 0. And its axis of symmetry would be at x equals h, and in this case it would be x equals 0. What the axis of symmetry does, or the axis of symmetry is a line that divides the graph in half, okay? And the graph of this shape is a parabola. So if we put a point at 0, 0, all right, and I'm going to do our axis of symmetry is x equals 0. Well, the line x equals 0 is actually the y-axis. So your axis of symmetry goes right through this graph, right down the y-axis. And for this f of x equals x squared, I'm just going to do a table of values. I'm going to do an x and an f of x, so you can see how this works. When you're graphing parabolas, once you determine the vertex, you can put the vertex in your table of values. And then what you want to do is you want to pick 2 points to the left of the vertex, and you want to pick 2 points to the right of the vertex. So for our x's, our inputs, we're going to pick -2, -1, because those would be 2 points to the left. And then 2 points to the right would be 1 and 2. Now when you do that, you've only got to do half the math. All right, because everything is symmetrical in a parabola. The graph of a quadratic function is symmetrical. So when we input a 1 for x, this 1 right here, if you take 1 and you square it, you get 1. So f of x would be equal to 1. If you input the 2, well, what's 2 squared? It's 4. Okay? Now, if you input this -1, -1 squared is also 1. And -2 squared is also 4. So you can see you only have to do half the math if you pick 2 points that are the same distance from the vertex. All right, so if we plot these points now, 0, 0 is already on the graph. Then we got 1, 1 right here. And then 2, 4. 2, 1, 2, 3, 4. So there's the right side of the graph. Then we're at -1, 1. And we're at -2, 4. Now, when you're graphing these, just try not to make them a V, because the bottom of this graph is actually a curve. And then we're just going right here. So that is the graph of the function of x is equal to x squared. While we're here, we're going to talk about one more item on this graph. All right, in this graph, since A is positive, and the graph goes up, it has a minimum value. And that minimum value is 0. These parabolas, that you're going to be asked for the minimum and the maximum value. If a graph goes up, it has a minimum value. The minimum value is the y value at the vertex. Since a is positive and the graph goes up, it has a minimum value of 0. And we can say the y value at the vertex. And we'll do one here in just a second where the graph has a maximum value, all right, which means the graph goes down. And when the graph goes down, it has a maximum value, and the maximum value is the y value at the vertex. All right, so let's do another one of these. Let's graph the function of x equals 1/2 x squared. Function of x equals 1/2 of x squared. So just like the previous problem, this is the same as f of x being equal to 1/2 times x minus 0 squared plus 0. Vertex would be at 0, 0. Axis of symmetry would be at x equals 0 again. So when we graph this, I'm going to put a point at 0, 0. Our axis of symmetry goes right down the y-axis again. And we're going to do a table of values. So we've got an x, f of x, and inputs of 0, 0, or one of the coordinates is at 0, 0. Now, when you're inputting and your a is a fraction, or when you're choosing points and your a is a fraction, you want to kind of think ahead a little bit. All right? You're going to square something and then take half of it. So wouldn't it be nice if it was an even number? Okay? So if you squared a 2 as an input, if I square a 2, I get 4. What's half of 4? 2. So now, if I put a 3 in here, I'm going to square 3, I would get a 9, right? But if I square 4, what do I get? 16, and what's half of 16? 8. So by being a little bit creative or thinking forward a little bit in your inputs, you can get cleaner outputs, and it makes your graph simpler to graph. So we're going to also use a -2, which would produce a 2, and a -4, which would produce an 8. And now we're symmetrical. So if we've already plotted the vertex, we can plot this 2, 2, and we can plot 4, 8. And then we can reflect them. All right, and then we're going to round out the bottom of this graph. And there's our f of x. Equals 1/2. x squared. This graph has a minimum value again. Has a minimum value of 0 because it opens up. Everybody all right with that? All right, so let's talk about some graphs that look a little bit different. Now we're going to have to graph each function. Graph each function. How is it translated from f of x equals x squared? If we take a function like g of x equals x squared minus 5, now what we gotta remember is this: it's the same as g of x equals 1 times x minus 0 squared. And now look where this minus 5 is. It's to the right of the x squared, so it's out here. So let's look at the vertex of this graph. The vertex of this graph is going to be at 0, negative 5. The axis of symmetry is going to be x equals 0. And which way does this graph go? Does it go up or down? This value in here between the equal sign and the parenthesis, that's your A value. If that's positive, that graph goes up, okay? If it's negative, then your graph goes down. So this thing goes up, doesn't it? Now, look, this graph is the same as f of x equals x squared. It's the same graph, but the vertex is in a different place, all right? So all as it does is it looks just like this, but since our vertex was at 0, negative 5, it's this same graph, but it's your vertex is down 1, 2, 3, 4. Your vertex is down here, okay? So if you had to graph this thing, here's the xy axis. Our vertex now is at 0, negative 5, so 0, negative 1, 2, 3, 4, 5 right here. Axis of symmetry is the same. It goes right through the vertex or right down the y-axis. You can do a table of values, but you don't really need to because we're not going to be getting that precise. Look what the relationship of these points were. From the vertex, we went over 1 and up 1, and then we went over another one and we went up 1, 2, 3, right? So we went right, up, 1, 1, and then right 1 and up 3. So right one, up one, right one, up, 1, 2, 3. There's the right side of that graph. Here's the left side of the graph, just reflect it. And then just try to get your bottom in there rounded out. There's your graph of f of x equals x squared minus 5. So the idea behind this right now is to see whatever's out here in this function. What direction did that move the graph? This moved it down 5, didn't it? So what if this was a negative 6 out here? Right? What if it was a positive 5? If it was a positive 5 out here, wouldn't it just be the same graph, but up 1, 2, 3, 4, 5? Same shape, right? Everybody agree with that? Okay. So now let's look at one where there's a change inside the parentheses. Change outside the parentheses moves the shape up and down directly. Okay? Up and down directly. Inside the parentheses, g of x equals x minus 4 squared. That's the same as, again, that's the same as g of x equals 1 times x minus 4 squared plus 0. Now our vertex is at hk. All right? So our vertex is at 4, 0. And another way of saying the vertex at hk, our vertex is at the opposite of whatever's in there with the x. All right? The opposite of what's in there with the x. Our axis of symmetry, that's always our x value at the vertex. So our axis of symmetry is going to be x equals 4. With that information, we don't need a table of values. We're going to go to the point 4, 0. So 1, 2, 3, 4 on the x-axis. Since the a is still 1, all right, we're going to have this same graph. We're going to go right 1, up 1, right 1, up 1, 2, 3. Reflect it. Curve the bottom. So look what this did. A value inside the parentheses. What can we say that a value inside the parentheses does? Doesn't it move? Go ahead. Moves what? Go ahead, Nick. Well, if this a is 1, yes, and all these other values, and you're only changing what's in here and what's out here. If this a is 1, then the graph will have the same shape. And these numbers here and here, they only move the vertex. Okay?
So are we going to get one where that's not open?
Yeah. Yeah. And that's the next thing we're going to talk about. All right? So the one thing you want to understand about this is that it moves it left to right, and I'm going to put opposite. That's not very good handwriting right there. Moves left to right, opposite. Meaning, since this was a -4 in there, it moved the graph to the right 4 units, didn't it? All right. Now, up here, these values outside, this moves up and down. It moves up and down direct. Meaning, if that's a -5 out there, it's moving this graph down 5. All right, so take a look at this. Let's look at function of x equals, let's say it's negative x minus 2 squared plus 3. Let's talk about the vertex. Where would this vertex be? 2, 3, good. Axis of symmetry. Very good, x equals 2. Graph going up or down? Got that negative sign, that's a -a, so our graph's going down. So this is it right here. We need the point 2, 3, and we're going down. So 2, 1, 2, 1, 2, 3. There's 2, 3. We're going down though, so we're going to go over and down 1, over 1, down 1, 2, 3. Reflect. Now we're rounding out the top. There's our graph. Now our graph is said to have a maximum value. And in this case, our maximum value is this 3 right here. That's the highest y value of this graph. It's going to be at the top of the vertex. Better? Better idea what we're doing? Now, one more thing I want you to get in your notes. Reflection, stretch, compression. All right, when A is equal to positive or -1. Remember we said we had a graph that looked like this for the positive one and this for the -1. As your A value, as A gets greater than 1, your graph will do this. It will stretch. It'll get taller faster. As your A value increases from 1, it goes to 1, 2, 3, 4, 5, 6, 7. As that A value gets larger, that graph gets taller faster. As A gets less than 1, this graph starts to get fatter. And that's called compression. That means A is a fraction. All right? This would be A being like a 1/2. Positives are still going to go up. Negatives are going to go down. Symmetrical. Okay? So if you're given a function, function of x equals -2 times x minus 4 squared plus 7. You could be asked for the vertex. Where's the vertex of this one? Good, 4, 7. What's our axis of symmetry? Axis of symmetry, that's our x equals 4. What direction does the graph go? It goes down, good. Since the graph goes down, it's going to have a maximum value, right? Graph goes down, it's going to have a maximum value. What's the max value of this graph? Good. Maximum value is 7. Now, the last thing you could be asked is, how is it reflected, or how is it translated from f of x equals x squared? It's going down, so it's flipped over the x-axis, right? And isn't our a greater than, our a value is larger than 1. It's just a negative number. You get me? So is this thing stretched or compressed? Very good, it's stretched. So without doing a table of values, look what you can do here. You can take this thing, right? You can go to 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. We go to 4, 7. We can put a point right here. Agreed? There's our vertex. It's going to be stretched, so it's thinner, and it's going down. So it's looking something like this. Yeah, yeah. Now, you have to know how to physically graph it, right? By putting in x's and getting f of x's out, right? But for me, you don't have to do all that. As long as you know where the vertex is, you know what direction it goes, you know that it should be a little bit skinnier, right? I'm good. You don't need to sit here and start plugging in the points and that doesn't matter to me. As much as the most important thing is right here. Here's all the important data about this graph. All right? Unless somebody asked you, what is f of x when x is 3? Well, you know how to do that. You just plug it in. But if you can look at the equation, you can determine where the vertex is, the axis of symmetry, what direction it goes, if it's got a minimum or a maximum value, and is it stretched or compressed? You know everything about the graph. All right? So if you're asked to graph one, I don't need you to do a table of values. I just need something that looks like what I just did right here. Clear? Because if you can do that, you know what the graph should look like. All right, so let's do this. Here's your practice for today. Page 199. Let's do 11 through 25. 27. 11 through 25 and problem number 27. All right. So that's going in the basket, or you're going to email me a picture when you're done. Thank you. E-learners, your practice pages have been uploaded to the resources tab. If you don't have any questions, you're excused from the meeting. And we'll do this again tomorrow.